I've got a problem up here on the board. We're asked to find the volume enclosed by these two planes, x equals plus or minus 1. That's going to give me two planes parallel to the yz plane. These two planes, y equals plus or minus 2, that's going to be two planes parallel to the xz plane. And then these two surfaces, z equals e to the x plus y, and z equals negative x squared minus y squared. Now what we've seen so far is if I have the double integral over some region of some function of x and y, that's going to represent signed volume. That is not what we are asked to find here. We are asked to find volume. Volume is a geometric quantity. It is always positive. Well, if you have a degenerate shape, it could be 0, but volume is never negative. Signed volume can be negative. Now, we have seen when our integrand is positive, so that the height function that we're integrating is positive, then the signed volume will be positive and it will be the same thing as volume. But they're not always going to be the same. Okay. So I can use this, but only if I rig it so that I find a function that represents the height as a positive quantity of the shape that I'm working with. So what I want to try to do is get some sense of what's this region whose volume I'm being asked to find. So my guess is that right now you're all in some sort of a room. And I'm going to guess that that room has a floor and a ceiling and 4 walls. Okay, I could be wrong. Some of you might be up in an attic somewhere, and sometimes with an attic the floor and the ceiling meet. And if the floor and the ceiling meet, then you don't really have to have a wall there because the floor and the ceiling meeting takes care of that. Some of you might be trapped in a tower, a nice circular tower where you're being kept captive by a witch and waiting for somebody to come rescue you or to escape. So then you don't have 4 walls, you have one big round wall. But I'm guessing most of you have 4 walls and a floor and a ceiling. Okay. And that's essentially what we're going to have anytime we're integrating over a rectangular region. The rectangular region is going to determine the walls, and then the floor and the ceiling, unlike the room that you're probably in right now, are not necessarily flat and parallel to each other. They might be curved surfaces. Okay. But I can see these planes here. Those would just be the extrusions of lines in the xy plane. And if in the xy plane I draw in x equals 1 and x equals negative 1, I did negative 1 first, and y equals 2 and y equals negative 2, that's defining this rectangle right here. I'm thinking that's going to be the region over which we're integrating. That's going to essentially be the common domain for the floor and the ceiling that we have for our particular function. And if I just extrude these lines, that's going to define basically when y is constant, that's going to define a left wall and a right wall. When x is constant, that's going to define a front wall and a back wall for my region. So then these functions, one of them is going to have to be the floor and one of them is going to have to be the ceiling. That's assuming that they don't cross and trade places. Sometimes we'll have a situation like that where something starts out at the ceiling and then it crosses and becomes the floor. We're not going to have that here because if I look at this function is always positive. This function is always not positive. It's 0 at the origin and negative everywhere else. So I can see this function is basically going to be my ceiling. I can spell ceiling. And this function here is going to be the floor. Or I could say the ceiling is the top surface and the floor is the bottom surface. Now, if you were to measure the height of the room that you're in currently, you would measure the distance between the floor and the ceiling. And to ensure that you got that as a positive value, you could actually calculate these things as a difference. The height of the ceiling minus the height of the floor, because your floor isn't necessarily at ground level. Okay. So if I want to find volume, that's going to be the double integral over r. Again, in this section, we're going to restrict ourselves to regions that are rectangles, but we're eventually going to learn to work with all sorts of regions that are in 2 space. I'm going to integrate the height, which will be the top minus the bottom. By subtracting in that order, I'm ensuring that I'm getting a positive value for the height, which means when I integrate, I should get something positive. Because we always set up our integral so that our limits of integration go from smallest value to biggest value. So with respect to x, we're integrating from back to front. With respect to y, we're integrating from left to right. That ensures that we're counting the area of the base as positive, so that if the height is positive, we will get a positive volume as well. Now, that's not to say that we can't do something like a u substitution that then has us integrating from a smaller value to a bigger value. But when we're setting up our integrals, it's always understood that we're setting it up so that that dA represents a positive change in area. Okay, so I'm thinking that means that I can set up this integral. We'll be going from -1 to 1 with respect to x. We'll be going from -2 to 2 with respect to y. And if we're doing top minus bottom, it's going to be e to the x plus y minus the quantity x squared minus, negative x squared minus y squared. So I'm not integrating these functions individually, I'm integrating the difference between them. Top minus bottom gives me that vertical distance, which is going to be the height of things. So I'm just going to simplify this a little bit before I integrate. First of all, I'm going to just use rules of exponents to say that that's e to the x times e to the y. Not absolutely necessary to do that, but that really keeps them as separate factors, which is kind of nice, so that when I'm integrating with respect to y, this whole factor e to the x will be considered constant. Okay. And then I'm just going to distribute this negative, so it'll become plus x squared plus y squared dy dx. Okay, excellent. So that's going to give me the integral from -1 to 1 dx. That's my shell. And inside there, I'm going to do this inner integral. So antiderivative with respect to y is going to be e to the x, e to the y. Wasn't necessary to rewrite that. I could have done this keeping it as e to the x plus y. I'd basically be doing a quick u substitution. U would be x plus y, and du would be the same as dy. Okay. Plus x squared y. X squared is constant with respect to y, so I get that constant times my variable, and then plus y cubed over 3. And that's all evaluated between 2 and -2. And these were values that I was plugging in for y, so we're going to have the integral from -1 to 1 of e to the x times e squared plus 2x squared plus 8/3 minus, and I'm going to put some parentheses here because I'm subtracting the whole thing I get when I plug in -2. So that's e to the x times e to the -2 minus 2x squared minus 8/3, and we're integrating this whole thing dx. Okay, let's go ahead and distribute that negative, see if we can combine any like terms, and then we'll do the integration with respect to x. So we've got the integral from -1 to 1, e to the x times e squared plus 2x squared plus 8/3 minus e to the x times e to the -2. This is going to become plus 2x squared plus 8/3, and we're integrating that dx. So it looks like I can combine my x squareds and my 8/3. If I wanted to, I could combine my e to the x's, but I think I'm going to just keep those separate. So we've got the integral from -1 to 1, e to the x e squared, plus 4x squared plus 16 thirds minus e to the x times e to the negative 2. And now we've got to integrate that with respect to x. Okay, so that's going to give me e to the x times e squared plus 4x cubed over 3 plus 16 thirds x minus e to the x e to the negative 2. And all of that's evaluated between 1 and negative 1. So we're going to get what we get at 1 minus what we get at negative 1. I like to have those parentheses there so that I don't forget them. When I plug in 1, I'm going to get e to the first times e squared. That's just going to be e cubed. Plus, this will become 4 thirds plus 16 thirds minus, this is going to be e to the first times e to the negative 2. That's going to be e to the negative 1, or if you prefer, 1 over e. When I plug in negative 1, I'm going to have e to the negative 1 times e squared. That's just going to be e to the first. Okay. Here, this is going to become minus 4 thirds, minus 16 thirds, and then minus e to the negative 1 times e to the negative 2 is e to the negative 3. Okay, so let's distribute that negative and combine any terms that we have. So, e cubed plus 4 thirds, plus 4 thirds plus 16 thirds. Let's go ahead and make that plus 20 thirds. Minus e to the negative 1. Distributing this negative, minus e plus 4 thirds plus 16 thirds plus e to the negative 3. So that's another 20 thirds. So I'm going to have e cubed plus a total of 40 thirds from this piece and this piece and this piece, okay, minus e to the negative 1. I'm just going to write that as 1 over e, minus e plus e to the negative 3 is 1 over e cubed. Okay, I think that's as far as we can simplify because these guys aren't like terms. I could, if I wanted to, get a common denominator, but I don't want to, and there's really no need. Okay. What I do like to do, since we were finding a volume, this should be positive. And I'm pretty convinced that it is. Okay? I do see these two terms are negative. However, e cubed is going to be a lot bigger than e. So this positive term will counterbalance this negative one. And 1 over e, that's between a half and a third. The 40 thirds is way bigger than that. So the positive parts are clearly bigger than the negative parts. That's good because I was calculating volume. Volume can't be negative. Now, for some of you, this is tragic, but it will happen. You will be calculating a volume and you will make a mistake. And you will get an answer that is clearly wrong because it's negative. And so, if this happens on, say, take-home work, you try to find your answer. You email, you call, you get help, you fix the mistake. Okay? But let's suppose this happens on a proctored test and you're running short on time and you are not going to have time to find the mistake, but you know it's wrong. Now, you could turn in the wrong answer and hope I don't notice. I do not recommend this strategy. I tend to notice these things. Okay? What I recommend is that you write me a note. Dear Carla, this answer is wrong. I know volume can't be negative. This makes me sad. But I wanted you to know that I know volume isn't negative. Sincerely and with much respect and admiration, and then you can sign your name. Okay. Now, that's totally counterintuitive because you're essentially saying, look, my answer is wrong, take off points. But what I hear when I read that note, especially if it's signed with much respect and admiration, I hear take off 1 point, not 2. Because if you are calculating something that clearly should be positive, and you turn in an answer that's obviously negative, I will take off 2 points because you made 2 mistakes. You made whatever mistake you made in order to get that wrong answer in the first place. And then you submitted it as if it was a reasonable answer. And one of the things that's a most valuable skill that you need is being able to recognize when you make mistakes. We're all human. We're all going to make mistakes. Okay? But let's say you're going into engineering and you've just calculated that you need to order negative 300 tons of concrete. If you go to your boss and you say, we need to order negative 3 tons of concrete, and the computer won't let me enter in negative 3, well, you're probably fired because you look like an idiot. Sorry. Okay? But if you say, oh, I just got negative 3, that can't be right. So then you go back and you check your work and you find the correct thing. That's saving your company time and money. Now, if you get an answer that's obviously negative, sometimes people say, oh, well, I should just change the sign. I should just make it positive. If you do that and I catch you, I'm taking off 2 points again. 1 for getting the negative answer, and 1 for assuming that the wrong answer you got was exactly the opposite of the right answer. I have made many mistakes in my life, even math mistakes. And I can tell you that there are times when I made a mistake and I got exactly the opposite of the right answer. But there were other times when the right answer was 5 and I got negative 3. It wasn't the opposite of the right answer. There are lots and lots of wrong answers. So if you got something negative, it is possible that you just made a sign error somewhere. So that's one place to look for that error. But if you can't find it, don't just change the sign and say, oh, well, clearly I made a mistake. The only mistake I ever make is to get the exact opposite of the right answer and change the sign, because that's actually a second mistake.